Guys, this is the second part of question number 5. That this is about here. You can see the first part we have done. That was bead needs to be moving along this horizontal smooth straight line wire AB. The length of AB is 3 meter. It is given here. You can see. I'm going to underline this. This is given 3 meter. So by keeping this length in mind, the second part, initially the bead is at rest. It is like if I can draw this, so bead is here, AB is 3 meter apart and U is rest. Bead is at rest. It reached B with a speed of V is 11.7 meter per second. Find the mass of the bead M. We have to find M along with it from the first part, as we know that the relation between, we know the S, so 2as, we need to find acceleration as well. 2as is equal to v square minus u square, which is third equation of motion. So here a will be v square minus u square over 2s. So let's see with what acceleration it will reach at from A to B. So V is 11.7 square minus 0 square over 2 times of 3. That was given distance between the A and B position. And after calculation, we will get 22.8 meter per second square. This was the acceleration with which the bead will move from rest from point A to point B. Now, as we have to find the mass of the bead and it is driving, so we can say the driven force minus resistive force should equal to ma. And it is clear in the question that the wire was smooth, so for the smooth we know this restrictive forces will be 0, and m we have to find, a we have already calculated, and the driven force as you can see here, what will be a driven force we are talking about the resultant one, r. So this is r cos 15, because this is a resultant force which will let the bead to drive, yeah, which will let the bead to drive on the wire. So that is, I'm going to write it here, that is r cos 15 degree, as we had done in first part. So and the value of this is what r we have calculated in the first part. R was 12.4 cos 15 degree is equal to 22.8 m. So m will be 12.4 cos 15 degree divided by 22.8, and after calculation we will get it 0.525 kg. Right, this is the mass but the bead keeps while moving from point A to B. I hope it is clear. In the question number 6, it is stated that particle P moves in a straight line starting from point O. The velocity of P measured in meter per second at time t after leaving O is given by this. Velocity given by this. Fine. Verify that when t is equal to 5, the particle is 6.25 meter from O. It means this is the distance. So first we have to calculate the distance, as we are given the velocity 0.6 t minus 0.03 t square. For the distance we need to integrate it. The t is equal to 0.6 integral t dt minus 0.03 t square dt. So this comes to be the displacement, that is 6.25 given. 0.6, it will be t squared by 2, and 0.03, it comes t cube by 3 plus c. So for value of c, for c at, we know point O, initial starting point. We know T was 0 and S was 0, so it implies that C was 0. So we can say S is equal to yeah, 0.6 by 2t square minus 0.03 by 3t cube, right? Now further we can simplify, and even we can replace the value of t here, s here, that is 6.25 given in the question. 0.3 t square minus 0.01 t cube. As we have to verify it, verify it. Okay, don't put the value of s we have to verify. So at t is equal to what? 5 seconds, it must keep the 6.25. S is equal to 0.3 into 5 square, 0.01 into 5 power 3. Let's do the calculation on calculator. I will get 24 by 4, and that's give me 6.25 meter, hence proved. So we have proved this, verified this, that when time is 5, the particle will cover a distance of 6.25 meter from O. And also it's given find the acceleration of the particle at this time. At this time. We have to find this time in what time? 5 seconds. So now we have to find acceleration at t is equal to what? 5 seconds. So for acceleration we know dv by dt will give us acceleration. So from start this, we will get dv by dt, that is 0.6 minus 0.06 t. So at t this comes to be what? A, and 0.6 minus 0.06 into t is 5, so we will get 0.3 meter per second square the acceleration. I hope it is clear. Let's proceed to next. Okay guys, in second part it's given find the values of t, more than one values of t, for at which the particle is traveling at a half of its maximum velocity. For maximum velocity, you know, we have to find this and equate to 0, minimum maximum, right? Because the quadratic curve, so the shape will be like to this and like this, it should be here. Okay, we have to find values of t. The particle is traveling half of it. Let's start it. We are given 0.6 t minus 0.03 t square the velocity. So for for dv by dt, you will get 0.6 minus 0.06 t. So make it equal to 0 to get t. 0.06 minus 0.06 t equal to 0. So t will be 0.6 divided by 0.06. I will get t, calculator, it comes 10 second, right? So t is what? 10 second. So now we have to find the maximum velocity at 10 second. So v at 10 will be 0.6 times 10. I'm replacing it here. Plus 0.06 and 10 square. With the calculator I will get it 6 minus 3, that is 3 meter per second. Now it's given half of v, that is say we get 3 by 2, it gives me 1.5 meter per second. Now speed is this, so we have to find the time when it is maximum, half of the maximum velocity. So this was the maximum velocity at 10. So let's see. So in 1 I can put it, this is 1, replace v with 1.5 and 0.6 t minus 0.003 t square. Simplify it 1.5, and if I can further remove the decimal whatever, after simplifying we should get t square minus 20t plus 50 equal to 0. It means divide each term with 0.03 and you will get this thing, right? So, and by using calculator, it's a quadratic equation, so it will t is one answer. I will get 2.96 second, and other t is what? T is what? It's is 17.07. These are the answers. Second, these are the two values of t where the particle is traveling at half of its maximum velocity. I hope it's clear. Okay guys, now the final question of this paper. A cyclist starts from rest at point A and moves in a straight line with the acceleration this. Okay, fine. Distance is covered by 36 meter. The cyclist then travels at constant speed of 25 seconds before slowing down with constant deceleration to come to rest at B. It means again, as it's starting from rest and it has to come to rest at B. So better to draw the VT, you know, graph. You are first to write what is given. You are given here A is 0.5 meter per second square. U was initially at rest 0 meter per second, and distance was what, 36 meter. Okay. And we have to find the total time that the cyclist takes to travel from A to B. Okay, fine. So first of all, if we can better, we can draw the graph, VT graph. For that I need time. So if we're using first equation of motion, that is what time when uh, start with, yes, the cyclist travels at constant speed of 25 uh, speed for 25 seconds, right? And the distance AB is total distance starting from to end point is 210, right? We have to find V as well. The final when reached at B with speed after 25 seconds, what is the maximum speed? Okay, so we can use the Newton's third equation of motion. V square minus u square is equal to 2as. So v square is equal to u square plus 2as. So v square we have to find. U is 0 square plus 2a was 0.5 and it was 36. So using calculator, and we get this thing, and v is 6 meter per maximum speed is 6 meter per second. And now at time when it will come to this speed, so v is equal to u plus 80. V is 6, u was initial rest, and a was 0.5 t. So t will be 6 divided by 0.5, t is 12 second. It means at 12 second it will be at the maximum, but 6 meter per second. Now we can draw the graph, VT graph, better to justify our answers. It's VT. Suppose this is what, this is 3, this is 6 meter per second, and this is time is in second. And here time was what, 12 second. It will attain this speed of 6 meter per second. And it is given that cyclist then travels at a constant speed for 25 seconds. So we have to add 25 with it to become a 37. I hope 37 is here, because this will be 12 plus 25 is 37. Yes, exactly, it will come here at 37 seconds. It will move with the same constant speed as given this one before slowing down with constant deceleration. Then deceleration and comes to rest at B. So suppose this is A point here, this one starting point and ending point. We suppose this is B, and we don't know what time it will reach at B, but it will come decelerate like down here, right? Okay, and it is also given the total distance AB is 210. We will use it. So we know that from sorry is this is what page, yeah, it's back now. Okay, with this I have to I have given total distance AB is what, 210 meter. I wrote it here, this is given. So from the figure, let me do it here. I make two parts. Make two parts. So from figure, I know total distance is what? This is area under the VT graph is represent distance. This one A2 and A3, right? So total 210 is equal to 1 of 2 half base into height. Sorry, 6 plus this is A2 is what? A2 is rectangle. I'm going to change the color. This is 25. So 25 by 6 and plus again the final one A3 is what? A triangle, right angle triangle. So half base is what? T minus 37 and height is what? 6. Okay, that comes to be 200 and it should be 67 210. Now we will solve this as it will be 210 is equal to 260 is 36 plus 25 6 25 6 we get 150 plus 2 6 2 3 is 6 3 into t minus 37. So do the calculation, we'll get 24 is equal to 3 into t minus 37. So 8 is equal to t minus 37. So total time is what? 8 plus 37 is 45 seconds. This is the time, total time taken for the cyclist to travel from A to B. I hope it is clear.